Hello. Making these videos are pretty difficult for me because I never prepare for them and I just pretty much go off the top of my head. Maybe I should do a better job at that, but basically I'm an IT guy, not a movie maker or an actor or a video maker. So um, please bear with me and I apologize if I jump all over the place or whatever, but I kind of wanted to share um, one of the many things that I'm learning and working with and doing on my own time is that of container orchestration. In containers in general, orchestration, you've got Docker Swarm, and more recently you've got Kubernetes, which pretty much has become the de facto right now in container orchestration. So this is not so much a tutorial or anything like that, or a how-to on Kubernetes. So it assumes that you already have the basics of Kubernetes down for the most part. This video is pretty much just showing Amazon EKS. So that's the Elastic Container Service, and I find this really interesting because it is basically a full-blown platform by Amazon that implements, allows you to run Kubernetes clusters on top of this, and it does managing for you, and it does it, the AWS way, highly efficient, optimized, integrates with all of the other AWS components that you've come to know and love, from S3 to ELBs, running within your VPC and all that kind of good stuff. So making a disclaimer, I am by no means an AWS expert, nor am I by no means a Kubernetes or a Docker expert. I've taken quite a few courses in Kubernetes and Docker and played around a lot with the technologies, but that does not make me a guru or any qualified individual. So, to come across as a qualified teacher or instructor. So anything I say can or may be used against me. Please look it up, reference it, and, I don't want to say take it with a grain of salt, but there's plenty of courses out there that show you that dive into Kubernetes in general. So I'll just leave it at that and assume that. So a quick brief history on, EKS and such, and why they're so late in the game. And this is coming, hearsay. I've heard it from other people. I've read it in blogs and all that. Amazon had ECS up until about 2016 or mid 2016. They were really pushing that hard, and I don't mean that in a bad way, and I mean no disrespect. They were pushing it very hard. At the same time, Docker Swarm was one of the most popular orchestration-based systems for containers and all that. But Kubernetes, open source project by Google, has pretty much overtaken Docker Swarm, and to the point where Kubernetes runs on Azure. It runs on I think OpenStack. I want to say that, but it might not be correct there. You can also set up Kubernetes to run on your own machines on-prem if you want. So there is no dependency to any kind of cloud vendor or platform, if you will. So it's very portable, and you can basically take your whole cluster orchestration-based system and take it off of one cloud vendor, put it on another cloud vendor. I'm oversimplifying it, of course, but the idea is it attempts to abstract and not be dependent, on a specific, cloud vendor or set of, Linux machines or whatever. So I probably didn't say that in a really good way, but anyways, Amazon realized that Kubernetes had pretty much become the de facto, so they worked hard this year and came out with EKS. And what I mean by worked hard is, Azure was kind of ahead in that area because they had AKS for quite a while and gained a lot of popularity and such. So, just recently you've got EKS, and I think there's going to be some really good things coming out with it, and I think it's only going to get better and better. There are, basically, why EKS? Why would anybody use this? instead of setting up your own. Well, Kelsey Hightower, who's one of the main gurus of Kubernetes, I think he works at Google and all that. Um, he has, he has a tutorial and all that, and I've actually gone through all these steps, and it's quite a bit. But for the most part, you can, install Kubernetes on your own VMs, a set of Linux boxes or whatever, and there's quite a few components involved. So just real quickly for those that are not too familiar with Kubernetes, you've got a Kubernetes master. These are all like different nodes, but you got a Kubernetes master, and then you've got your worker nodes, and then you have a bunch of components that run on your master, and then you have components that have to be agents that have to be installed in your worker nodes. On your master, you've got your controller manager, whose purpose in life is to make sure that everything is healthy and that your pods are all running to the desired state, and that basically everything's running the way you specify inside of your deployments, replica sets, and things of that nature. And then you've got your scheduler that's basically going to communicate, back and forth to each of these nodes to make sure the pods are running. And again, a pod is like the smallest unit of quote unquote work in Kubernetes, but a pod can contain one or more containers that are running. So throughout the life cycle, you've got your pods can be balanced across different nodes. Your pods can come and go. They can die, if you will. And when they die, it's like the job of the controller manager and the scheduler to make sure that it kicks off new pods, in order to meet the desired state, meaning, the minimum number of nodes that you want to, or quote unquote replicas that you want to have running. So I guess what I'm saying is there's an awful lot involved with the cluster itself if you want to install it manually. And again, if you want to really be old school and do it the hard way or give it a shot, you can go through the exercise. Like I said, I did, and but you got to run it on the Google Cloud platform for this tutorial. But it gives you a pretty good understanding as a part of the exercise and all that. In order to get these different components to be communicating to each other, you also have to create self-signed certificates in order to because they all communicate through SSL and things of that nature. So EKS basically says you don't have to do any of that stuff. Just start using our service, and if you create a cluster, basically we will provision and create all this stuff for you right here. And then you can go ahead and create, you can create Cloudformation templates or whatever to create your different worker nodes. AWS has a few AMIs out there. One such AMI actually comes configured and installed. It's a Linux one that comes configured with these components here for the worker node. So you don't even have to bother with installing that. You just basically have to run a little Cloudformation template or a config map, if you will, which sets up the role so that your different worker nodes can communicate back to your master node. These nodes itself running on AWS will be EC2 instances. So again, you get the benefit of Amazon EC2 and the whole subnetting, and the whole cluster itself is going to run within a single VPC, and these nodes can span availability zones, things of that nature. One of the things I probably will forget to mention it, but based on the types of applications, are usually microservices that lend themselves best to these container-based systems, orchestration systems. But one of the things you have to kind of watch out for is if you have some of these pods, if you have some of your pods running across different availability zones, when you're running into the issue with stateful sets within Kubernetes, or if you need to have a shared volume per se, EBS volumes can't really span availability zones. So what you're going to have to do there is you're going to have to start with, like within Kubernetes itself, you're going to have to create persistent volume claims, which basically allow you to link the pods across your different nodes to an EFS, which is considered a best practice, an EFS share, which contains your volume. So that way you can have your pods, running stateful applications across different nodes, um, all sharing the same piece of data, if you will. But I think I'm kind of deviating. I just wanted to mention that EKS actually installs the stuff out of the box, and it makes it relatively painless for you, if you will, to set up your clusters. One of the other things about EKS is there is no free tier available for it, so you will pay a flat rate of 20 cents per hour. So when you're doing these tutorials and such, one of the things I did is I made sure that I basically went through a lot of the tutorials, ran them, and then basically deleted my stack. And then everything I'm going to show you is based on, I'm going to try to go and run this example guest book application, but you can actually go to, the site here, and they do have tutorials that show you how to get things up and running with EKS. And I'm just going to kind of go through real quickly and not really show you all the steps, because I'll leave that up to you. But you can go right here and you can go through some of the tutorials. But I'm going to go ahead and just show you the Kubernetes dashboard thing that you can get from GitHub and installed, and what that looks like. And I'm going to go ahead and create the cluster and a couple of worker nodes. So periodically I might be pausing this video because it takes time to create some of these clusters and nodes. So having said that, one of the first things that we're going to do is, go ahead and make sure that you have, kube control set up. And kube control basically is a command line interface that will allow you to talk to your clusters, if you will, locally. So here I am back home on my own PC, and once I spin and create these this EKS cluster, I can communicate and send instructions to the master control plane. So again, if you want to learn more about Kubernetes components, you've got your master node and your node components, you can actually go to Kubernetes IO, and there's a whole bunch of good stuff here that explains the purpose of all the different components. So I'm not going to actually go through that.